In our lesson video today, we're moving on to lesson 3B.4, and we will be talking about another kind of quadrilateral called a trapezoid. And we're going to look at the different properties and characteristics of trapezoids and some special or unique trapezoids. But these are not going to have any of the properties of parallelograms or rectangles or rhombus or squares, because trapezoids are not going to fit those same categories, because our main characteristic of a trapezoid is that there is exactly one pair of parallel opposite sides. And so actually we're going to write that as our first property here. Okay, there's exactly one pair of parallel opposite sides, and those parallel opposite sides are called bases. All right, the two sides that are parallel are called bases. Usually we indicate that as base 1 and base 2, or it doesn't really matter which one's on top. Base 1 and base 2 are the parallel opposite sides. Okay, so that's our first characteristic of trapezoids. Okay, and there really isn't a whole lot else to go off of a basic trapezoid here. The non-parallel sides of a trapezoid, however, are kind of important to indicate, and those are called legs. Okay. All right. Now, we want to talk about some of the other characteristics or properties of a trapezoid. All right. What you're going to notice is that with a trapezoid, we have different angles. The angles that share a base are called base angles. And our third property of trapezoids is that the angles that share a leg will always be supplementary. Okay, remember supplementary angles add up to 180 degrees. And so what that tells you is that angle A here and angle D would add up to 180 degrees. And you should recognize those are consecutive interior angles of those parallel sides. The same thing with angle B and angle C. All right, so those are our properties, and we're going to use those properties to solve some problems. Okay, most of this is as simple as understanding which two angles would be supplementary. So number one here, this is a trapezoid. We have angle J. Its other base angle would be angle K. However, the angle that would be supplementary to J would be this other angle that shares this leg, and that would be angle M. Okay, so angle J and angle M will add up to 180 degrees. So I'm going to do 180 minus 87 here, and I get 93 degrees. So the measure of angle M is 93 degrees. When I need to find the measure of angle K, though, I'm going to use angle L, because those are supplementary. So the measure of angle K is 180 minus that 51 degrees, which would be 129 degrees. Okay, so remember, angles that share a leg, meaning the ones that don't share the bases, they are not side to side along the parallel line markings from each other. They share a leg. Those are supplementary. Okay, so on number two, we've got another trapezoid. Angle A and angle D share this leg, so they're supplementary. So I'm going to do 180 minus 62 to get the measure of angle D, and that is 118 degrees. And then angle B and angle C share a leg, and so they're supplementary. So the measure of angle C is 180 minus 31 degrees, which would be 149 degrees. Okay. Now, I'm going through this a little more quickly, but I'm doing the calculations, a lot of these either in my head or I've done them before, so I remember the answers. But again, just use your calculator to do these subtraction problems if you need to, or write them out, do them on paper, whatever you're used to doing. But on some of these, we have a little bit more work to do. And again, we're still basing this on that one property. And so I'm actually going to indicate that here, that I'll just say leg angles are supplementary, or angles that share a leg are supplementary. Okay, and so that means I can add these two expressions together and it will equal 180. And so that's how I set up the equation here. 8x plus 6 plus 54 is what equals 180 degrees. And then we just solve. Let's combine our like terms first, 6 and 54. That makes it 8x plus 60 equals 180. Then we subtract 60 from both sides, leaving 8x equals 120. And then we divide by 8. And so if I do 120 divided by 8, I get 15. So x is 15. Okay. Now, just like we've been doing in our other lessons, we always want to start by identifying the property that allows us to set this up. But for trapezoids, it becomes a little bit easier. Same property is going to be used here, that angles that share a leg are supplementary. Okay. And these two angles, Q and R, they do share a leg. And so they actually ask me to find the measure of angle R this time. So the first thing I want you to do is to set up an equation knowing that these two angles are supplementary. It means that you're going to add the two expressions, set them equal to 180, solve for x, and then we're going to plug back in here to find the measure of angle R. I want you to pause the video here and give yourself some time to work this out. When you get your answer, click play to check your answer. All right, if you're done and ready to move on, this is the answer you should get. Your equation should give you that x is 10. And then when I plug back in, the measure of angle R ends up being 57 degrees. Okay, let's keep on going. We have another kind, a special kind of trapezoid we're going to look at. When we look at this kind of trapezoid, this is called an isosceles trapezoid. Now, the word isosceles was used when we talked about triangles, and it was where two sides were congruent. Again, the property of an isosceles trapezoid would just mean that there are two sides that are congruent. However, it will not be the bases. We still have two opposite sides that are parallel, exactly one pair of opposite sides parallel. The other sides, or the legs, are congruent. And that's our new property here, that these other sides that are not the bases, the legs, are congruent. Now, we have our properties of trapezoids that still work out. I'll go ahead and write them out individually this time. The angles that share a leg are still supplementary. But we have some new properties here we're going to look at. This is one of those new properties. And then the other properties are involving, first of all, the base angles, the angles that share a base. Now, all four angles could be called base angles, but we're talking, when I say base angles, I'm talking about two angles that share a base. And the base angles are congruent. That means angle A is congruent to angle B because they share the base AB. And angle D is congruent to angle C because they share the base DC in an isosceles trapezoid. We also have another couple rules to look at. Because base angles are congruent, we can actually say that opposite angles are supplementary. Since A is the same as B here, and B and C are supplementary, that means opposite angles are also supplementary. Okay? All right, and we have one other property to look at. And so as we look at this last property here, Let me get my pen working. The last property we're going to look at deals with the diagonals. Okay? Now, when you draw the diagonals, you'll notice that they intersect each other. They're not going to bisect each other. They're not going to go through the middle. They're not perpendicular. That all can be changed. But there's a unique property for the diagonals, and that's this. The diagonals intersect to form proportional segments. What that tells you is these two segments are congruent and these two segments are congruent, okay? And that creates a proportional relationship between those intersections. And remember, proportion again is something like A over B equals C over D. Okay? So let's start using some of these properties to find some values here. So you'll notice that if I mark this as an isosceles trapezoid, okay, we're told they're isosceles, plus they mark the congruent legs here, that's going to be something where they only give you one angle measure if we're talking about angles, because we know that base angles are the same. Okay, so if X is 47 degrees, W is also 47 degrees. And we know consecutive leg angles are supplementary. So the measure of angle Y is 180 minus 47, which is 133 degrees. Okay. But the opposite angles are also supplementary, or you could think of these two congruent base angles. So I know Z is also 133 degrees. Okay, so it looks like you're not given very much information, but you don't need very much as long as you know it's an isosceles trapezoid. Okay, again, an isosceles trapezoid here, but this time we're finding a specific value using an equation of some kind, and they want you to, I want you to be able to list what property we're using. In this case, the property we're using is the property involving opposite angles. Well, remember up here, opposite angles are supplementary. So that's my property. So my equation is going to add these up to equal 180. Okay, we combine like terms again. All right, subtract the 4 from both sides. That gives us 16x equals 176. Divide by 16. And when we divide by 16 here, we should get that x is 11. But that's not your final answer. They want to know, this directions are asking for the measure of angle z. Well, the measure of angle z doesn't have an expression. However, remember, base angles are congruent. So that's actually another property I could use. All right, so I'm going to plug in here, and that'll be the same as the measure of angle z. Six times 11 is 66, and 66 minus 1 is 65 degrees. And so the measure of angle z is 65 degrees. Okay, let's keep moving right along. We've got another one. Now, there are two different variables in this equation, or in this problem, so there's going to need to be two different equations used. So let's look at what we're doing. MP is 16x minus 13, and NO is 9x plus 8. Well, MP is a leg. NO is the other leg. This is an isosceles trapezoid because we're told that it is. So those are congruent. That means one equation that we can use is those are equal. The property we're using to find x is that the legs are congruent. So we can set up that equation to find x. But I want us to, before we just jump right into finding x, if you want to pause the video here and find it yourself, you're welcome to. But I do want us to pause and look at what we're going to do to find the value of y. Pn and MO are the diagonals. Now, we talked one thing about diagonals, and I actually forgot to write a property down. There's an extra one, so I made a mistake there. Let's go back and take a look at that. So the diagonals intersect to form proportional segments. I just need to add to that. There's one more piece to that we're going to do, and we can, when we're stating properties, you can state these separately. So you can think of these as two separate properties or just all one. And that's also that diagonals are congruent. Okay? The diagonals of an isosceles trapezoid are also congruent. All right? So that's actually the property we're using here. The properties to find y is that diagonals are congruent. Sorry, I left that off the first time. So we can just set those equal to each other. 5y plus 19 must equal 12y minus 37. And if we didn't, you'll notice I didn't write the other formula yet, or the other equation for x. The other equation for x is 16x minus 13 equals 9x plus 8. Okay? And so let's just go solving these one at a time. On the x equation, we're going to subtract 9x from both sides. When I do that, I get 7x minus 13 equals 8. And then I'm going to add 13 to both sides, and I get 7x equals 21. Dividing by 7 on both sides, we get x equals 3. Okay, found x. Now we can go through and solve for y. I'm going to subtract 5y from both sides. That gives us 19 equals 7y minus 37. Add 37 to both sides, and 19 plus 37 is 56. And then we divide by 7 on both sides, and we get y equals 8. And there are your answers for x and y. All right, let's move right along here. Okay, we're told in this one that STVU is an isosceles trapezoid, making these congruent legs. I didn't put a blank for it, but I do want us to identify the property. Well, V and T are opposite angles. And again, in an isosceles trapezoid, opposite angles are supplementary. Okay. What I want you to do now is to set up your equation based on that property, solve for x, and then we'll look at how to find the measure of angle S. Okay, this is what we should have gotten from our equation for x. X equals 12. Remember, when we say supplementary, it means they add up to 180. Okay, so x is 12, but they want to know the measure of angle S. Well, remember, base angles are also congruent in an isosceles trapezoid, so I know that the measure of angle S is equal to the measure of angle T. So to find the measure of angle S, I'm going to use this expression and use 12 for x. 3 times 12 plus 1 gives me 36 plus 1, which is equal to 37 degrees. And that's the measure of angle T and the measure of angle S. All right, there's one other category we want to talk about with trapezoids. All right, so trapezoids, again, they're these four-sided shapes where there's one set of parallel sides that are called bases. Those are always going to be different lengths from each other. The other two sides that are not parallel are called legs. Now, most of the time, if it's just a trapezoid, if they don't tell you it's isosceles, then those legs are not going to be congruent. However, if they are congruent, that makes it isosceles. But with any trapezoid, we have something called trapezoid midsegments. And there's a couple things we need to know about midsegments. And there's some special calculations they help me understand. First of all, we need to know what a midsegment is. Okay, so first, a midsegment in any trapezoid, whether it's isosceles or not, a midsegment is a segment where the endpoints of the segment are the midpoints of the legs. Okay, and you can see that indicated here. E has to be the midpoint of AD because they mark AE congruent to ED. And F has to be the midpoint of the other leg, BC, because they're marked congruent segments BF and FC. And remember, when I mark each end of that segment congruent to the other, that means the point in the middle is the midpoint. Okay, So a midsegment is a segment where the endpoints are the midpoints of the legs. All right. Now, the other characteristics tell me what I can understand about that. First of all, that midsegment is always parallel to the bases then. Okay, so a midsegment is parallel to the bases. So in our example, AB is parallel to EF, which is also parallel to DC. All three of those segments are parallel. But we have one final thing to talk about with midsegments, and that comes to the length of the midsegment. The midsegment length is the average of the base lengths. And remember, average means we add them up and divide by 2. So in this case, the length of EF is equal to AB plus DC all divided by 2. Okay, so we can use this specific diagram with an example here. To do this example, we're going to say that AB is 14 and the other base, DC, is 26. That means that EF is the average of those, okay? There's two ways of looking about this. So part one, or the first method here, is to just use your formula. I'm going to add up base 1 plus base 2 and divide by 2. Remember, we add the top of that fraction together first. 14 plus 26 is 40, and I divide by 2. That is 20. Okay, so I know the length of EF is 20. But like I said, there's another way we can do that. And this kind of goes back to when we talked about finding endpoints and using some midpoints with some number lines, all right? So we're looking for the number that is exactly halfway between 14 and 26, okay? And so I could think of it like this. Think of a number line. If I've got 14 on one end, 26 at the other, I want to know what number is exactly halfway from 14 to 26. So we look at the entire length, and we would just do 26 minus 14 to find out what half that length is. Okay, 26 minus 14 is 12. So I take that 12 and I divide it by 2, and I get 6. So I'm 6 units away from 14 and 6 units back from 26. So it's like I do minus 6 from the 26, goes to 20, or plus 6 to the 14, and it's 20 again. Now that might be more confusing, but that's actually going to be very helpful on certain problems where I might give you the mid segment and one other base length, and you have to find the third base or the second base. Okay, so that's the second method for finding that. Either way, we get the length of EF is 20. All right, now on these next two examples, though, we do have to just basically set up an equation because they give you some algebraic expressions for the lengths here. Now we're told that in this trapezoid, YZ is the midsegment. We could even mark these as congruent and these as congruent, but we're looking for the value of that midsegment. That means first I need to know the value of X. So remember, the midsegment is equal to half of base 1 plus base 2. Okay, so in this case, YZ is half of base 1 PQ plus base 2 SR. Or we can jump straight to filling in our equation. Okay. Sorry, instead of YZ, we're going to write the expression for YZ. 5x minus 19 equals, the top of this fraction is base 1, 38, plus base 2, x plus 14, all over 2. Now, these equations can be a little bit complicated sometimes, but I want you to remember, anytime you have the entire side of one equation all over a number, in this case 2, you simply need to cancel that fraction out by multiplying both sides by that number. So in this case, multiply this side by 2, it just cancels it. but I have to multiply this side by 2 as well. So it's going to change the left side of this into 10x minus 38, because we distribute the 2 to both of those. But the right side, I'm not going to change, other than maybe combining my like terms in the same step, and I can do that. 38 plus 14 is 52, plus the x then. All I did was cancel the 2's. So now we can solve for x. What I'm going to do is subtract the 1x from both sides, giving me 9x. Okay, and then I'm going to add the 38 to both sides, and that actually works out pretty nice because that makes it 90. And so if 9x equals 90, x equals 10. Now, since they want the length of yz, I just plug back in. 5 times 10 minus 19 is 50 minus 19, which is 31. So the length of yz is 31. Okay, one final example here. Again, very similar. What I'm going to do is I'm going to let you set this up kind of the same way we did the last one, and get your equation, solve it for x, and then we're going to plug back in and find uv. I want you to pause the video and try this one on your own. If you need some help with it, or if you just want to check your answer, click play when you're ready, and we'll see what our answer should be. Okay, we should get this. All right, the first thing you'll notice is I set up my mid-segment length equal to base 1 plus base 2 all over 2. I went ahead and combined my like terms to get this line here. Then I multiplied both sides by 2, and then I solved for x. Once I got x, you plug back in for the length of uv, and you get uv equals 13. All right, that finishes our lesson on trapezoids. Make sure you go back and look at all this. If you have any questions, make sure you send me a message in Canvas so you can ask for some help on that. And then otherwise, you should be ready to start the assignment.